Yeah, so we're here just outside Preston. Been working on this church for a couple of weeks now, and we're going to put this Limecrete flooring today, so we thought we'd just do a quick video on how we do it and you know, see if we can help you if you want to do one. And yeah, so we've already got the foam glass in. The floors have already been excavated. We've put a non-woven geotextile down, and then we've put the foam glass in. I think that's gone in about 1.5 feet thick, and then we've covered it over with some more geotextile, ready for the Limecrete to go on. Also here we've put new drainage system in. We're doing some timber repair works. It's been a historic dry rot issues that have been going on here in the floors. So we've basically stripped out all the timber floors now and we're replacing them for a Limecrete. And then the external works that we've done for the drainage is going to try and lower the water table around the building. We've put new drains in everywhere. We've checked every drain on the building, making sure they're all working how they should do. A lot of the parts were silted up with sand and material, so they've all been jetted and cleaned. So this works now should help, like I say, lower the water table and dry the building out. We're mixing this Limecrete. We've got this machine. It's just got a mixer bucket on that we use for concrete, and you can see it's just got two big augers in there. And what it does is it just mixes the materials together using the auger, and it's just so much quicker than using a standard bell mixer or even mixing it by hand. So we've got this. We would have bought us a pan mixer normally to mix all this, but we had this machine on site, so we're just using this instead. So we've got some 10mm to 6mm gravel that we're using as the main aggregate in there. We've got some sharp sand. We're using a Waddyfell sharp sand at the minute, and Cecil NHL 5. The mix that we're using, we're batching it with buckets so that we get it accurate on every mix. And we're using 2 buckets of aggregate to 1 bucket of coarse sharp sand and 1 lime in there as well. And then we're putting some synthetic fibres in to bind it all together. And that's it. They just let it mix up now, and they'll probably mix it for about 5–10 minutes in this mixer, and they'll just keep adding water to it till we get it to the right consistency. We don't want it like a concrete mix where it's going to be wet and flowing, because you're going to get loads of shrinkage cracks when you do that. You need it to be like tight together, so there's moisture in it that's going to set the lime off, but then there's not too much moisture that when that moisture evaporates it's going to shrink and crack. So getting the consistency right is fairly is a fairly fine art, and it's something, probably one of the most important things that needs to be done when you're mixing the Limecrete, is having that moisture content right in it. Putting enough water in so it's workable and it compacts and it's labelled, but not too much so that you're going to end up with getting shrinkage cracks in it. Yeah, so you can see in the mixer here that you can still pick it up. It's not a flowing mix, but yeah, it will compact and bind together and give you a finish, and it's solid. So I mean, it's as simple as that, doing a test just to make sure that it's going to bind together and you're going to get a finish on it. You could probably put a little bit more water in than that, but that's it. Like I say, you don't want it like a flowing concrete. It needs to be wet enough so it binds, but not too wet so it flows. Yeah, so these are the fibres that we use. They are just a really fine fibre, and they're all in clumps at the minute, but when they go through the mixer they all break down, and it's just like little hairs, and it all spreads out through the mix. This is it's a concrete product that they use. A lot of this products you can get in the builders merchants are actually a thicker fibre than this. I don't like using them because they don't displace as well. These displace really well in the mix. You need an NHL 5 just for the strength, because you're using it as a floor slab. But you have got issues that you're using the least impervious lime to put in a breathable floor slab. We have done them before with an NHL 3.5, and you could also get away with using, say, calcium oxide or Calbux and put a pot slam with it. That'll give you a creamier mix. It would work. Never done it. Like I say, we have done some floors with 3.5, but standardly they all come on NHL 5. now we've made this little shelf, we've got the laser at a better level. When it was up here, the laser's right at our side and it'll flash you as you're working. And so what we've done, we'll move it down to this little shelf where it's out of the way and it's not going to get flashed in your eyes. It'll start spinning and then that's it, it's all done. It automatically finds its own level. It's a railway spec level is this, so it doesn't actually give off a red light like normal laser levels do. So yeah, what we've got, and then we've got a receiver here. So this receiver detects the, we'll just take it off here. This receiver detects the laser and then it gives you a reading there. What are we on, 26 mil down. And then it comes all the way to 0. And then it goes up actually the other way as well. So what we need to do now is set this to the finished floor level existing that we've got and find that level first. If I was doing it without a laser, what I would do is I would level off my floor, we're taking off 25 million off as finished floor level. So what I would do is I'd knock pegs in around the room so that I've got a gauge throughout the room of the level that I need to be at, and then I would either leave the pegs in or then take them out after and then fill the holes in. So there's ways of doing it without the laser, but it just makes it a lot easier. Yeah, so what we're doing, we'll just find this finished floor level that we've got in here, and we'll set the staff and the receiver, so that now anywhere in this room we'll finish this the floor level that we've got existing, but we need to allow for the tile and the adhesive that we're going to use. So what we need to do is add 25 mil on, because then that'll send the staff down and it'll make it a deeper dig. So there we go. So that gives us the top of the Limecrete where we need to be, and that'll be 25 mil below the finished floor level. So that's going to be his finished floor level. So anywhere in this room now, this staff will tell us the finished floor level that we need his Limecrete to, and make it a lot easier to put in. What we've done is we've set these guardrails up now, so we've used as laser level and as staff. So these are 2 millimeters out, so I'm all right with that. So what we've done is we've put these rails in, and we're using these as a guard to screed off the Limecrete floor. As you're walking all over it, you're compacting the screed down. Some of the edges where you're not walking, you kind of got to tamp it in with your feet. And then what I generally try and do is leave about 2 inches low, and then I go over the top then, put some more Limecrete on top of it, and then I tamp it down with the urethane float, which is going to be higher than the actual rails. Then I screed off, we've just got a feather edge that we use for plastering here, screed it off with a feather edge and then rub it up with the urethane float, and then you just continue back. So you kind of want to put the base in 2 inches lower than where you need to finish, and then use the guardrails, bring it up, tamp it in, screed it off, rub it up, job done. What you see we've done now is work this back edge out, and we've still got these timbers in. So what we do is we just pull them down as we're working, and just then go back and fill the hole in. So what we do is just rebed up the timber further back, and then you can just gently wobble it out, pull it back, and I've bedded this up a bit higher than what I need to, because you can just get his laser level on there again, and then just get it back down to where we need it to be. Yeah, again, 2 mm, spot on. Yeah, so what we can do as well is just check it randomly on here. You see we're knocking between 2 mil up and 0, so it's good enough as that. And yeah, so we just sporadically check it as well, just make sure his rails aren't out as we're working his way out of the room. Watch the rails. He's a good boy. When we took the timber floor up from in this building, it was horrendously bad with dry rot, so we excavated down the material so that we could get the new formed glass in here. This site around this area is a really sandy, kind of clayey sandy material. So when we've got the formed glass in there, the Limecrete slab will go on top of it, and that'll be ideal for furniture and other objects around the house or building in general. If you're looking to then actually build onto the slab with you know, a wall or a structural, put something structural on there, I wouldn't recommend actually putting that onto the slab directly. You would need to preempt that when you're digging your foundations. You could then build that up and then Limecrete, put your formed glass and Limecrete around there and have that directly onto a foundation below, because the spread on the Limecrete slab, you don't get the same strength as you do with concrete. So just for general house and building items, that's fine, but nothing structural really wants to go on top of this slab. What we've done is we've left this, it's going to be a service trench because we've got heating pipes to go through here. So we've left it out, and then what we've done is we've put this piece of wood on to create a little lip in it, and then we'll put a flag over the top of that, and then we'll tile over the top of that. So we've just used this timber just to make a little step in the floor. When you're looking at Limecrete over concrete, you've got just the breathability issue with concrete, that if we was going to put a concrete slab in this, we would put, you know, standard PIR insulation under it, and then we'd visqueen it to stop any moisture coming up, and we'd wrap that up the walls. And basically all the moisture that will be then driven out into the walls of the building. Whereas what we want in this Limecrete slab to do is handle any moisture that's underneath there, would then percolate up, and the slab would handle a lot of the moisture. It would ebb and flow the moisture just the same as it does when you render or point a wall with lime. You have this holding point with the Limecrete floor. You don't actually want it to percolate up and all the way through. If you've got that much moisture in your room, you've got issues externally again with groundwater. And like I said before, with this building, you generally have to do, with the Limecrete floor, you have to do the external work as well and put the external drainage in and lower the water table. You can't expect a Limecrete floor to handle a high water table. It's not going to do that, and it will end up failing. So it's got to be in conjunction with external works where, you know, you've got a high water table, you want to drop that down, but you still want that breathability. You've got breathability in walls, and then now you're going to have breathability in the floor, and it's going to ebb and flow moisture and handle moisture inside the building a lot better. You'll see here we've dug out about 3 foot away from the building, and we've cleared all the earth back down to foundation level. And what we've done, we've put a land drain in, and we haven't used the flexi weavy land drain because it's horrendously hard to get it to actually lay to a level. A lot of people use it and they put it in, but a lot of times when we've excavated it in the past, it undulates up and down. It hasn't been fit correctly, so we never use the flexible weavy coil pipes. We use standard 110 mil underground pipe, and you can get it slotted so it will act as a land drain, or you can just slot it with a grinder. And we've put that in and actually laid it to a level around the perimeter of the building. So now what you're going to get is you're going to get evaporation from all this area to the side of this building, and the moisture is, you know, it's going to come off this grass, and it's not going to then penetrate all the way up to the building. It's going to hit this layer of aggregate and then go into the land drains and then off away from the building, and before it gets anywhere near the building, and it's going to act as this big buffer to stop the moisture from the ground transferring through to the building. And we've also changed all the gullies while we've done the pipe work. All the gullies have been changed because when we come originally to do the drain survey around this building, the drains we couldn't rod them, we couldn't put the camera down them because they're all trap gullies. But we've changed all the gullies now for new. They're still trap gullies, but they're actually roddable now. They've got a little bung in the top where you can actually rod the pipe. So anybody wanting to look at this drainage system, or you know, if there's a blockage in the future, it's going to be far easier for them to find and trace the drains, and also to, you know, jet or rod them if they need to. Thursday today, so we'll leave it tomorrow, and then Monday what we will do is probably get some 9mm ply, something like that, put some 9mm ply down it just to spread the load while we're working in here, and then yeah, just it'll dry out then over time. What we'll do in the evenings, before we go, we'll lift the ply up again so that it can dry and overnight, so it doesn't all condensate on the back side of the ply, and then we'll keep going. We've put some normally on these jobs we'd use like a cork insulation board or a fibre board around the edge, but we've gone for like it's just a standard brick insulation, if you will. It's like a foam. I've said before, we've got historic issues of dry rot, and in this room the floor was absolutely covered in it. So later on, after we've done this next week, dry rot guys are coming in to do some wall treatment here, and we just don't want to be putting a natural material like cork into the walls where, you know, we've had historic issues of dry rot, because we could end up with future problems with it inherently going into the cork board. So that's why I've opted for this foam instead.